This video will help you find domain and range of a graph in interval notation. So before we start off talking about looking at domain and range of a graph, we actually need to know what domain and range are. Domain are all the possible x values. Domain can also be written as the input values or the independent variable. So domain are always the x values. That's specifically what domain is. The range, on the other hand, are all the possible y values. The y values could be called the output values. And range is also known as the dependent variable. So again, domain are the x values and range are the y values. So when we talk about interval notation, there are 4 things you want to fill in to interval notation. So notice the 4 blanks that are here that we want to fill in. The first blank and the last blank will be either a bracket or a parenthesis. Again, the last one will be either a bracket or a parenthesis. So the major question is, how do I know if it's a bracket or a parenthesis? Brackets are used when the value that we have written right next to it is included in the domain or the range. Another way to kind of think of this as is the value is closed, which means that there would be a closed dot or something that would look like this in the graph. On the other hand, a parenthesis is used when the value is not included, which means that it's open. And again, it could be designated as an open dot, which would look something like this in your graph. So the dot's not filled in. So again, depending upon the if the value is included or it is not, it'll be brackets or parentheses. Inside those brackets or parentheses, you first put the smallest value. So that's what comes first inside the bracket or parenthesis. And then after the bracket or parenthesis, or sorry, after the comma, my apologies, we put the largest value. So the largest value is coming right before the second bracket or parenthesis. And notice in between the smallest value and the largest value is a comma. So now we know what interval notation is and how it's written. I just want you to be aware there are multiple ways to write interval notation. Notice you can have 2 parentheses, you can have a bracket and a parenthesis in any order, you could have 2 brackets and so on. So these are all the possible ways to write interval notation. And if you look at the number line sketches, it's very clear as to which is which. One thing I need to point out here is this symbol that we see. This is the infinity symbol, which means that that value just keeps increasing. There's no bound, no largest value in that data set. Because if we say B, we know C is a little bit bigger, D is a little bit bigger, and so on. So we put infinity to designate the biggest number that there is. And if you notice, with all of the infinity symbols, there are parentheses on them because that value is not included. Infinity is technically not really a number, so that value, infinity, is not included. All right, so let's look at some examples of finding domain and range on a graph. So I'm given the following graph, and I want to find the domain and range. So let's start off with domain. So with domain, we are only interested in the x values. The x values are like the width of the graph. So what I'm going to do, so that way we don't get confused, is I'm going to cover up all these y values because I do not need them in order to find domain. So again, notice I'm just coloring over them so that way we don't get confused. We're only looking at the width of the graph for domain. So first of all, we want to start off, we have 4 things we want to fill in. The first thing we want to do is find the smallest value, then we want to find the largest value, and then we'll determine brackets or parentheses from there. So looking at just the width of this graph, what is the smallest possible x value that you see in the graph? So I see this is the smallest possible x value, which reads at a value of -4. So there's my smallest possible x. Again, we're only talking about x because we're talking about domain. And then now we want to find the largest possible x. So again, we're looking at the graph. The largest possible x, again, looking at the width, is 3. So my largest possible x value, 3. Now we need to determine if we put a bracket or a parenthesis on both of these. So the -4, if you notice at -4 there's an open dot. An open dot means that an open point or that value is not included, which means we put a parenthesis. So now we need to determine a bracket or parenthesis for the 3. So we look at 3. We noticed it is a closed dot, which means that value is closed, which means that value is included. So we put a bracket. So overall, my domain, written in interval notation for this graph, looks as follows. -4 to 3, with 3 being included and -4 not being included. All right, so that was just domain. Now we need to look at range. So range, remember, are the y values, the output or the dependent variable. So this time, I'm only looking at the y values. So since I'm only looking at the y values, I'm going to cover up all these x numbers. Because again, I'm not interested in the x anymore. I'm interested in just the y for the range. So I'm looking at the height of the graph this time. So the smallest possible y I see is -5. The largest possible y I see, again, we're looking at the height of the graph this time, is 2. So now I need to determine if I put a bracket or parenthesis on each of these values. So -5 on the y, again, we're specifically looking at y because we're dealing with range, has an open dot. An open dot means that it's not included, which means we put a parenthesis. And then 2, there's no dot at 2, so we don't know necessarily if it's open or closed, but we are able to determine 2 is on the graph. That's the highest point. And since 2 is on the graph, that means it's included. If it's included, we put a bracket. So my domain, written in interval notation, is -5 to 2, including 2. All right, so let's try another example. I'm going to find domain and range of the following graph. Remember, domain are the x values or the width of the graph, and range are the y values or the height of the graph. So again, just like I did before for domain, I'm going to kind of white out all these possible y values for right now, because remember, domain, we only are looking at the x's. And I'm going to find the smallest possible x and the largest possible x, and then I'll put brackets or parentheses on them accordingly. So the smallest possible x I see in the picture is -4. But please realize this arrow designates that this graph continues on and on forever in this direction. It's not included in the picture. So when we talk about the smallest possible x, notice -5 is in that graph if I extend it. -6 will be in that graph. Will -100 be in the graph? Yeah, it will be. So we want to choose the smallest possible x that's in the graph, not necessarily in the picture though. And in this case, the smallest possible x is -infinity. So now we need to look for the largest possible x. So again, I'm looking at my graph. The largest possible one is 5. Notice there's no arrow. So 5 is where the graph ends. Please remember, infinity always gets a parenthesis no matter what. And then 5 has a closed dot, so that value is included, which means we put a bracket. So my domain for this graph is any value less than or equal to 5. Or we can say from -infinity to 5, with 5 being included. All right, so now we look at the range. For range, remember we're looking at the y values. So just like before, this time I'm going to cross out the x because the x does nothing for us this time. I'm trying to find the smallest possible y and the largest possible y. So again, the smallest possible y that's in the picture is -5, but is that the smallest possible y in the graph? No, it is not. The smallest possible y, notice again, -6 is in the graph, -7 is in the graph. So the smallest possible y is -infinity. And the largest possible y is 2. Infinity always gets a parenthesis, and 2 has a closed dot, so we put a bracket. So my range for this graph is -infinity to 2, with 2 being included. Let's try just a few more. Again, we want to find domain and range of the given graph. So domain are the x values. So again, we're only looking at the width of the graph. Range are the y values. We're only looking at the height of the graph. So domain. We're only again looking at the width. The smallest possible x value for domain would be -infinity, because this arrow designates that the graph continues on and on forever and ever. So my smallest possible x, -infinity. Look at my largest possible x. The largest x in the picture is 5, but because there's an arrow that designates it continues on and on forever. So my largest possible x is infinity. And infinities always get parentheses. So range, again, we're looking at the height this time. Looking at the height. The smallest possible y that's in the graph is that's in the picture is -3. But remember, the graph continues on and on forever. So eventually, it's going to get to -4 and -5 and so on. So my smallest possible y, -infinity. And because I put infinity, I'm putting a parenthesis. My largest possible y, in the picture it is 2, but again the graph continues on. That's what the arrows mean at the end. So the largest possible y will be infinity, and because we put an infinity, we put a parenthesis. All right, so here's another domain and range of a graph. Again, domain are the x values, range are the y values. Domain is the width, range is the height. So smallest possible x for domain in the graph. Again, we're only looking at the width. It does continue on and on forever. That's what those arrows indicate. So in the picture, it ends around 2, but it continues on and on forever. So we put the negative infinity. And the largest possible x, again, in the picture, it looks maybe this time about 1.5, maybe close to 2. But because the arrow means that it continues on, you know the biggest possible x is infinity. And because we put infinities, we put parentheses. Range, remember this time we're looking at the height, so we're ignoring the width, we're looking at the height of the graph. The smallest possible y we see, again the smallest possible one in the picture is -5, but because we have the arrows, that means it continues on and on forever, which means we have negative infinity as the smallest possible y. And the largest possible y, notice there's this peak at 4. It doesn't go above 4, so my largest possible value is 4. Parentheses are always on infinity. And because 4 is in the graph, it is included, it's a closed value, we put a bracket. So number 5 here, I'll give you a minute or so to try this on your own. We want to find the domain and range of the following graph. So domain, remember those are the x values. So I'm looking at the width of the graph, the smallest possible x here. Please realize that a lot of the times some graphs won't put these arrows at the end. So you need to know that they're continuous, as opposed to the first view that we saw, there was a definite dot where it ended. There was a definite dot where it ended. If those dots are not present, always make sure you assume the arrows that it continues on and on forever. So the smallest possible x here is negative infinity. The largest possible x is positive infinity. So your domain is negative infinity to positive infinity, where both values are not included. As for a range, we're looking at the height of the graph. So the smallest possible y actually occurs a few times, but it's at the same point each time. So my smallest possible y is -1. My largest possible y, again, occurs a few times, but notice it's all at the same point of 1. So my range is -1 to 1, with the -1 and the 1 being included. So as a summary, domain here is negative infinity to infinity, and range is -1 to 1. Thank you for watching this video. As an extra credit opportunity, if you come down to my room to complete a quiz over this topic by October 12th, each correct answer on the quiz will be worth 2 bonus points. which is a total of 16 bonus points. Please take the opportunity that's given to you to raise your grade.